Well, we may as well get started because we don't want to run too over time today and we've got a lot to get through. How's your day been? Been pretty good? Yeah? Well, it's good to hear. My name's Graham Burton. I'm a consulting systems engineer within Cisco. And today we're going to go through on-premise meetings with Cisco Meeting Server. When I first built this presentation and I was given this topic, my main focus and my main objective of building this presentation was to try and really pass on as much information as I could around what I wanted to learn when I first learnt the product, as well as understanding all of its concepts and components. What I want for you guys also is to not only gain the fundamentals of the Cisco Meeting Server and its components and its infrastructure, but I want, at the end of this session, you guys to have a good understanding of how to build your own single combined server and build your own POC if you want to. And it's very simple to do that. So hopefully at the end of this, you'll have a great understanding of what all the components are and feel comfortable in actually building something for yourselves. Now, this session is focused on Cisco Meeting Server. It's not going to be focused on Cisco Spark, CMR Cloud, CMR Hybrid. It's purely a Cisco Meeting Server presentation. And usually the content that I'm going to go through usually is done over 3 days. So I've got 90 minutes and I don't want to kill you guys with a lot of information, but there is a lot of information that I want to try and get through. So today we're going to go through CMS and its fundamentals, its components that make up the Cisco Meeting Server, the architectures in where we put and how we place the Cisco Meeting Server in our own environments, and the API of the Cisco Meeting Server. Being that we haven't got a huge crowd here, if time permits, you can ask questions, and if it's too long, I may defer it. But otherwise, I'm happy to make it a little bit interactive if we can, if time permits. So to start off with, I've actually hounded Plantronics, and I've got some really cool giveaway prizes because I really want to get your good ratings. So I've got some really cool headsets here. So I've got a bit of a quiz, and I've got some giveaways to give away during the presentation as well to sort of inspire interaction and so forth. So to start off with, this looks weird, but can anyone tell me what this is? Close, but what is it? Yeah, that's pretty good. Anyone can tell me what brand of token ring card? You're a champ. It does. You must have. That's why you set up the front, isn't it? So you could read all the fine detail. It is. It's a Madge Networks token ring ISA card. And you guys are thinking to yourself, what does this have to do with Cisco Meeting Server? Some 20 plus years ago, a group of uni students formed a company called Madge Networks. And Madge Networks were pioneers in token ring technology. They built the company to over $1 billion net value, and they took it up to the likes of IBM and so forth. At one stage, even Cisco licensed their technology and put that into their switches and routers. And they eventually sold that business off. But that same group of guys wanted to keep innovating and keep disrupting the market. So they built a company. They saw a big opportunity first in IP telephony and toll bypass. So they got into IP telephony and they built a company called Callista. Now, Callista was very quickly acquired by Cisco and now forms part of our communications manager platform as you know it today. But they wanted to keep innovating, they wanted to keep moving, they didn't want to stay static. And they saw a massive hole in the conferencing market. People weren't communicating. The bridges that were out there at the time were very inflexible, very expensive. So they went out to the market, they got a massive list from all the customers and partners of what a conferencing bridge would look like. And they got this list and they took it to the engineering department and they said, build it. But what they didn't tell them is that no one could actually do everything in a single platform. And thus the Codeon MCU was born. And a lot of people possibly in this audience today have either utilised, have installed, or even still have today the Codeon MCU, because it was a very powerful bridge and it disrupted the market very much. Wasn't long after that, Tandberg acquired Codeon, and that completed Tandberg's video conferencing portfolio. And then it wasn't too long after that that Tandberg became #1 in the VC space. And Cisco saw this and they needed to actually complete their UC portfolio. So Cisco acquired Tandberg. And that's where I come from. I come from the Tandberg acquisition, and I became part of Cisco at that point as well. But these same group of guys wanted to keep innovating. The technology that was currently in the market was still based on older DSP technology, and it didn't really achieve the any-to-any vision that everyone was talking about. The thing that we really wanted to do is have anyone come into a conference and make it very flexible and easy to use. And the other thing was scale. We wanted to be able to scale this platform, bigger and better than what we had available, and we found it very difficult to do that on DSP technology. So thus these guys went out and they formed a company called Acano. And Acano really was a ground-up startup that built a next-generation conferencing platform. And it wasn't long after that, in February 2016, Cisco acquired Acano. And in August of last year, Acano was fully rebranded and now becomes the Cisco meeting server. So I just wanted to give you a bit of an understanding around the guys who have built this platform weren't born overnight. They weren't, straight out of uni. These guys have been around for a while and it's built on some solid knowledge and solid technology. WebEx CMR, not today. We can talk about that later if you like. So what is the Cisco meeting server? It is a software-based platform that provides complete conferencing services in a flexible deployment model. It provides scalable video conferencing and scalable audio conferencing. And we also introduced into this platform web conferencing, or WebRTC. The same platform can also do streaming and recording of our conferences. And if you understand where Acano come from, like being a ground-up, fresh build-up of a startup company, they needed to make sure that they didn't just talk happily with Cisco product, but they needed to make sure that they interworked with every vendor. So baked into the platform, they built some of the proprietary protocols like Microsoft's RTV and Polycom's High Profile. We've baked that into the platform as well, so it works as a very good interoperability platform as well as an interoperability gateway. We also introduce a couple of new concepts called Spaces, and I'll go through what they are, and also Cisco meeting apps. And last but not least, as I mentioned before, these guys have been around for a while, and what they learnt through their experience is every time they produced a product, they'd come out with a product and then one organisation would say, that's great, but I need you to add this feature or change this or change that. And another customer would say something different. We need you to add this feature, we need that feature. And what they found was that was utilising good innovation time. So what they decided to do in the Cisco meeting server was actually build that functionality into the core of the operating system and then provide a flexible, open API so customers and partners can essentially develop applications and programs to make the Cisco meeting server work in the way that meets their requirements. And the functionality is built into the core, thus saving very good engineering time. So the Cisco meeting server is a true any-to-any platform. It's a single meetings platform where everyone is invited. We can have people on mobile phones, desktop applications, PSTN, any standards-based endpoint, virtually any HTML5 browser to come in, interoperability with Skype for Business, and any Cisco video hard endpoints and soft endpoints can all come into this one conference, one meeting, and everyone can communicate with full content. Now, this platform also enables us to work any which way we want. We introduced the ability to have personal spaces, and not just one personal space, but people can have multiple personal spaces. I can have a space for a project meeting, a space for an engineering meeting, a space for a customer meeting. I can have multiple spaces that I'm an owner of and use them for different types of functions of meetings, and have different PIN codes, and I can have multiple ways I can have my customers and partners connect. We can also still schedule spaces for the meetings that we want to have at a set period of time, and I want to schedule those on a daily basis. It also supports ad hoc escalation. So from Communications Manager, you guys will be familiar with pressing the conference button and just adding another participant to that call. And it fully supports that. And it also fully supports an interoperable gateway. So we can dial from Skype for Business or any other platform into our standards-based world natively as in a point-to-point call. So you may have seen something similar to this once before. Some of my builds look like they've gone missing, but that's okay. So essentially, from any pocket to any desktop is the Cisco Collaboration Endpoint Portfolio. So from browser to boardroom. Unified Communications Manager is utilised for our call control. We have customer care for our contact centre. The Collaboration Edge architecture to remove the boundaries of the network to enable anyone to communicate within our own environment. And the Cisco Meeting Server completes our conferencing sub-architecture within our portfolio. So this is now our preferred conferencing platform within our collaboration architecture. So what is the Cisco Meeting Server? I mentioned that it was a flexible deployment model. It can be deployed on a Cisco Meeting Server appliance. It can be virtualized on VMware or Hyper-V, so you have a choice of virtualization technologies. We can even stick it within a private cloud, within Amazon Web Services. This software-based platform has multiple components within that. So it's a single platform that has components that we enable or disable based on what role we want the Cisco Meeting Server to achieve. And I'll go through that in a bit more detail. Over and above that, we have the application programming interface to be able to add management applications, third-party integrations, and third-party applications into that. So it really is enabling us to modify this platform to suit our own requirements. Now, at the time of acquisition, Acano had its own hardware platform called the X Series server, and that was available in 3 variants. And the reason why I talk about this today is because a lot of people today currently still have this platform, and it's still a very powerful platform. It's going into support, so as we got acquired by Cisco, it didn't actually come across onto the Cisco price book, but a lot of people still leverage it and still utilise it today. So it's still fully supported. In a 2RU box, we're able to achieve 250 720 high-definition P calls in a single 2RU box, and then for additional capacity, we could just add more. The X2, which was sort of same size but half the compute, did 125 at 720p. And the X1, typically we use for firewall traversal, or what we call edge functionality, and I'll go through what that means in a moment. And you can see that that's a very small function. It really just enabled us to do firewall traversal. There was no VMware, so it was a bare metal install, so it literally had the Acano, now Cisco Meeting Server software, installed onto that platform. And then we trunked that to our preferred call control platforms. Now, after the acquisition, Cisco introduced in August of this year, or last year, sorry, the Cisco Meeting Server 1000. And the Cisco Meeting Server 1000 was based on the UCS C-Series, essentially chassis-based servers. And they were able to achieve 96 720p calls in a 1RU box. This does have VMware installed on it, and you install the Cisco Meeting Server over and above that. It's a single server with a whole bunch of cores that are packed into it to enable us to scale our video architecture. once again, we then trunk that to our favourite platforms as well. And just announced in February this year, we still don't have a huge amount of information on pricing and so forth, but we have announced it externally, is the new Cisco Meeting Server 2000. This is based on the chassis, the 5108 UCS chassis, and it has 8 B200 series blades inserted into it. So it's got a real big scale of a platform, and it takes up 6 RUs, but we can have up to 500 720p calls. Now, unlike the CMS 1K, this doesn't have any VMware. It's purely got the CMS installed on the platform without VMware. The key point to note is all of these platforms are all compatible with each other. Regardless of the hardware that you install it on, we can still create a very scalable and highly available platform regardless of the hardware compute that we're utilising. And that takes me into the VMware side of things. We can also install this on your own virtualization hardware. Approximately you get 2.5 720p calls per core, which is a hyper-threaded core. And for that core, we need 1 gigabyte of memory and 100 gigabyte of disk space. So very easily, you're able to spec your own Cisco meeting server to create your own, without utilising the Cisco meeting server hardware, you can install it on your own compute. You'll also notice up there we have an edge VM, a database VM, and a recording VM, and so forth. And as I mentioned before, the Cisco meeting server is a very modular and component platform that enables us to install or to be able to turn it on and turn off functions based on how we want to deploy it. And we can actually deploy things like a database VM for scale and resilience, recording VMs for, once again, distribution and streaming. So we can actually spin up multiple virtual machines based on what we need to achieve. So this is more of a reference document. You can read this and take it up a little bit later. I won't go through all of it. So let's look at the architecture and the components of the Cisco meeting server, and let's look at how this thing actually pulls together. So the Cisco meeting server is a modular component, secure modular component architecture. All of these components are signed by certificates and fully trusted by each other. So within the same software image, we have to trust the components that we want it to connect to. Now, in a single meeting server environment, we can actually create what we call self-signed certificates within the box itself and assign those to each of the components. But we do need to have external or public CA certificates for external connectivity. For example, if we want to have WebRTC externally facing, or integration into Skype for Business, where we need to have secure SIP trunks or secure SIP trunks into Communications Manager, we do need to have, obviously not self-signed certificates, but trusted or public CA certificates there as well. Some of these components that make up the platform, the call bridge. Now, the call bridge is if you want to think of it, it's the main component of the Cisco meeting server solution. It's the call bridge is where we conference all of the video endpoints, the soft clients, the WebRTC, the Cisco meeting apps, all of our devices and anything. That's what conferences them all together, and that's where all of the processing, the grunt is all required by the call bridge. The web bridge is purely only enabled if you want WebRTC connectivity. So if you want WebRTC either externally or internally, you need to enable the web bridge. The database is where we store all of the system configuration and the space and API information within that database. So the database is the single source of truth for the CMS. This is where it stores all of its information. And it is based on a Postgres database. The web admin is purely a web administration interface to manage and to configure our call bridge. So we turn that on if we need to, if we're going to configure our call bridge, we need to have the web admin installed. The XMPP server, once again, we only really need that one if we're utilising the Cisco meeting apps, and I'll go into a little bit more detail about that. The WebRTC, we need to turn that on if we're planning on deploying any of those, because that handles not only the signalling, but also the media for those platforms and those products. The recorder, pretty straightforward, I think. That enables us to record our conferences, and I'll go into a bit more around how that works in a moment. The streamer, once again, I think that's fairly self-explanatory. By enabling the streaming component, that enables us to stream conferences out to a streaming server. The H323 gateway enables us to neighbour or receive H323 calls into the platform. If we're utilising things like the VCS, where it does SIP to H323 interworking, in my opinion, it's best to utilise that because that also does BFCP to H239 interworking as well. But if we're in an environment where we don't have that luxury, we do have the ability to receive H323 calls directly into the platform. And then we have these things called edge components, and I'll explain where we use these in a moment. But edge components, we have the load balancer, and the load balancer is purely an XMPP proxy to proxy all of our XMPP traffic through to the XMPP server when we're doing firewall traversal. The turn server is our traversal relay, or traversal using relays server that really enables us to do firewall traversal. And the SIP edge, which enables us to do Office 365 direct federation and open federation, so we can receive Skype for Business and Office 365 calls into our organisation. So here's what we call a single combined deployment. This is a very basic deployment. In most cases, I wouldn't recommend it, but this is one of our common deployment modalities or common deployment methods, where we have a single server, single software instance with all of the relevant components that we need to turn on, that we want to have turned on within a single instance. In this case, we've got the XMPP server for the WebRTC and the Cisco meeting apps, the web bridge for our WebRTC interface, the call bridge, as I mentioned before, that's our conferencing, the turn server to provide traversal services, recording and streaming and so forth. Can anyone tell me why this wouldn't be a great solution in a corporate environment? We can probably add additional servers to scale. But if you look at, for example, most call control handles the signalling and not the media. So when it comes to firewalls, I mean, this is sitting in the DMZ. You've got multiple video endpoints connecting from multiple IP addresses through, massive UDP port ranges. It's going to be a nightmare to try and manage our internal firewalls because we're going to have a lot of devices connecting to it. It is still a valid architecture, but it's not something that we would recommend. What we'd probably recommend in more of an environment where we want to have external connectivity is what we call a single split deployment. Okay, so it's still a single server, but we're splitting that out into two components, and this is how we do it. First off, we deploy another Cisco meeting server virtual machine. Now, it doesn't cost any additional money apart from spinning up a virtual machine to deploy it, but there's no additional licensing costs to do that. And then what we do is we move the edge components, or the external components we want visible external, and the firewall traversal components into that edge server. So we move the web bridge for external WebRTC connectivity. We move the turn server for firewall traversal into the edge. And then we move the load balancer, as I mentioned before, that's our XMPP proxy, into the edge as well. And then we can also add the SIP edge for B2B and also Office 365 direct and open federation. So this is what we call a single split deployment. Okay, so it's a single deployment split into 2 instances. And then likewise, we can then have all of our video endpoints connecting directly to our CMS within our own environment. And then there's only a single connection between our core and our edge. Now, you may have heard me talk about this thing called spaces. And spaces were a new concept that Acano, now Cisco meeting server, has got. You guys may be familiar with CMRs, VMRs, rendezvous, meet me's. They're all the same sort of thing. This is a meeting room that enables video, audio, web, Skype for Business, really anyone to be able to communicate within a single space. They're always available, always on, they're like permanent meetings, and I can have multiple of them. I don't need to have, I don't have to have one that's allocated to me. I can have one that's allocated as my, engineering space. I can have one that's allocated as my sales space, one that's allocated as my personal space, and we can actually meet in different locations based on the type of meeting that I have. You may find, and I'll get into this in a little bit later, but the API still calls them as co-spaces. So originally they were called co-spaces, and then I think through some sort of some licensing they called them spaces, and that's what they're still called today. Now up on the screen you'll see a little bit of a diagram or a little screenshot up there, and you'll see this is what we call the in-app meeting experience, where we have all of the spaces down the left-hand side there, and you can see this person's got multiple spaces, and then you can also see when one of the spaces is in progress. On the right-hand side there, we also have what we had a persistent chat, where from Skype for Business and from within the meeting app, we could chat about what's happening within the meeting prior to the meeting, and then we can then launch from that app into our space and have our video meeting there as well. And we can have, once again, multiple people dialing in. I think as of version 2.0, Cisco made the decision to disable that persistent meeting chat. But if your organisation does still find it that they may require or they'd like to try that out, you can re-enable that via the API, but that is currently a disabled, we've actually turned that off. Now with WebRTC, it really is a true anybody can connect platform. Anyone can join from any HTML5 browser with no plugins whatsoever, literally by joining in, no plugins to download. So Chrome, Firefox, Opera are all HTML5 browsers, and we can join without any fuss, without any hesitation. Anyone really can join. Now for the browsers that don't support HTML5, where you've got Internet Explorer, Safari and Microsoft Edge, what we do is we actually cross-launch to the Cisco meeting app. So those people who don't run HTML5 browsers and don't support WebRTC, we launch an application, and that application gives them the same meeting experience as what they had before. Once we're in the meeting, we're able to share bidirectionally both ways into the conference from our browser. And we have the ability to have guest or user login. With guest login, all we need to do is click on a single link, and that link will take us straight into the conference. We enter our name, and we're now a participant within that meeting. So it's very, very simple for guests to join the meeting. With user login, we actually have an Active Directory synchronization. So we log in with our Active Directory credentials, and from them, once we've logged in, we then have in-app experiences where we can do things like invite others to the meeting, create additional spaces. We can even do things like, if I've joined the meeting from my laptop from WebRTC, I can actually then say I would like to use a fixed video room system because it's going to give me a better experience, and I can actually move my call to a bigger system or a different system from within the app as well. And also within the app we can do in-meeting recording. So by pressing the recording button within the app, we can start and kick off our recording if we so like to. The Cisco meeting server really does enable us to meet any which way we like. And what we mean by that is that we can actually brand the platform to actually have our own corporate look and feel to match our organisation's branding policies. We can brand the WebRTC not only with backdrops but also colours and logos. So when people actually join from their web browser externally, it looks like a corporate web page. It looks like part of their corporate branding. We can also brand the IVR. So when people have dialed in from a video system, they get greeted, welcome to ABC organisation, as well as voice prompts as well to then greet them using the corporate greeting. And likewise within call branding, we can do the same. We can brand not only the backdrops but also the voice prompts as well. Welcome to the meeting, press X to join the meeting, and so forth. The platform also supports a very large array of voice switched and continuous presence video layouts. And we can change those from within the app, we can change those from DTMF, and those who are utilising Cisco meeting endpoints, we can also change the layouts from within our Touch 10 as well, using active control. So from our Touch 10, we have the ability to change our layouts that were being sent from the CMS from within our touch panel, which makes it very easy to use. Now in 1.9 of the Cisco meeting server, which was just at the point of acquisition, we introduced recording, and recording enables us to record our meeting and we can do that via various different ways. And one of the ways is we can have our space automatically record. So whenever anyone dials into the space or whenever we join that space, it'll automatically start recording that session. We can also have the space start recording via DTMF. So by pressing a tone on our keypad, we can, for those systems that don't have, older systems where you've got DTMF, remote controls or touch panels, we can kick off the recording that way. We can also, through the Cisco meeting app, press the record button, and it's all administratively defined through the API. The way the recording works is we have a recording license, which is part of the Cisco meeting server license, and we apply that to the call bridge that is connecting to the recorder. So the call bridge has the recording license, and it sends the media to the XMPP server. The XMPP server then connects to the recorder, and the recorder then stores the file on a network file system, which you do need to have and you need to provide. That recording file is stored as an MP4 file in the format of the unique conference ID, followed by a date and time stamp. So then you can have other applications and other learning meetings, LMS platforms or other streaming media applications to watch that watch folder, take that file and manipulate it and do whatever you like later on. It does record the file at a 720p 30 video coding with 64K audio. And you can actually have turn on a recording server instance up to 32 recording ports on a single server using 16 cores. Now, if you're looking at doing sizing and how much space it's going to take to be able to store this, because it uses VBR or variable bit rate, it consumes between 300 and 800 megabytes per hour for that MP4 file to be recorded. So as a guide for sizing, we'd like you to sort of allocate about a gig per hour per record, just to give you a bit of headroom there as well. Now in 2.1, we also introduced streaming. Works very similar to the way the recording works, administrative applied through the API and can either be initiated from automatically when we join a space. And it works very similar. The call bridge will send the media to the XMPP server, and the XMPP server sends the stream to the streamer. The key difference here is that the streaming server URL is predefined in the API to point to a streaming server location. Now, straight after this session today, we've got the enterprise recording and live streaming architectures with Terry. And if you want to know more about this, highly recommend going to that session because he'll go into a lot more depth in recording and streaming, not only from the CMS platform, but from other platforms as well. So I've spoken about these components, and a lot of you guys are probably thinking, well, okay, that's great, but what components do I need to enable? What do I need to turn on or turn off based on what I need to achieve? So for example, if I want a Skype for Business gateway function, all I need to turn on is the call bridge for my conferencing, the web admin to be able to configure my call bridge, and if you're using Office 365, we turn on the Edge functionality, the SIP Edge functionality. Yeah, I'll get to that part in a moment because you'll see a little bit of an asterisk there and around the Expressway 8.9x as well. And so some organisations have already got either the Acana or Cisco meeting server in place and possibly don't have Expressway. But we're actually, I'll go through that in a little bit moment, but we actually are doing a bit of work there as well. Likewise for WebRTC, if I want to enable WebRTC within my organisation, once again, I still need the call bridge, which does all my conferencing, and in most cases I need the call bridge unless I'm doing something, making it do something else. I need the web admin to configure the WebRTC, the XMPP server, because as I mentioned before, the XMPP server does the signalling and the media for the Cisco meeting apps and WebRTC, and the web bridge, and I can either have that spun up in the edge or within the core as well. So you don't need to memorise all this, but it gives you an understanding that we turn on various different components based on what we want to achieve within the platform. The Cisco meeting server is very heavily reliant on DNS-A records and SRV records. This enables our other integrations, for example, Skype for Business, our WebBridge or WebRTC clients, and other components to be able to connect to it. So we need A records for the WebBridge and the call bridge, and we need SRV records for our XMPP server as a minimum. I won't go through all of this, and hence I've marked it as reference, but it is heavily reliant on these A records or DNS records to make this platform function. So just some general considerations when you're deploying the Cisco meeting server is, as I just mentioned, we do need to have the A records and SRV records created for our call bridge and our web bridge, and the XMPP SRV records for the XMPP server. When we're using a single split or a split environment, the core and the web bridge utilise ports 443 and 3478 for communication, outbound communication, respectively. And generally, and this is probably a big gotcha that a lot of people come to me and I sort of have to explain this to them, the Edge server generally requires two external IP addresses or public addresses. And the reason for that is if we've got the web bridge running on port 443 and we've got the turn server running on 443, they both can't run on the same interface because we have a conflict. Why do we use port 443? Because it's firewall friendly for other web browsers to be able to get out of their own networks and environments. So if we've got the both running on 443, then we need to have them on separate interfaces. The load balancer, which is the XMPP proxy, and the SIP Edge can either be installed on one of the other two interfaces as well. So we can have, for example, the web bridge and the load balancer on one interface, and the turn server and the SIP edge on another interface if required, but we do require two. The biggest gotcha though is that each of these external interfaces need to have public addresses and they need to be on separate subnets. I've had in cases where people, allocate public addresses, two public addresses to two interfaces and say, yep, that's good. But because of the underlying operating system, they need to have different default gateways, otherwise it doesn't function properly. Yep. Yep. Yeah, you can, but then you need to obviously spin up another virtual machine. Depends on your organisation. Yeah, absolutely. So let's look at resilience and scale, geodistribution and licensing. I'm only going to touch on licensing a little bit because it is meant to be a technical presentation, but as I mentioned at the start, a lot of people still ask me around, licensing. How does this platform get licensed? So to start off with, for scale, here we have a server in the APJ region with a couple of endpoints connected to it. To add additional scale and local resilience, and same location redundancy, all we need to do is add another server and cluster them together, right? And I'll go through how the clustering works in a moment. But that's all we need to do, just add another server. The licensing is shared or pooled across the two platforms, so really that just adds additional capacity. To add, and I mentioned that, databases are clustered automatically. So when a video system dials into one CMS and another video system dials into another CMS, being that the databases are clustered, it'll automatically set up an intelligent cascade between the two. So no interaction is required to join the two CMSs together once they're clustered. Once the CMS detects that someone has dialed into a space on one of the platforms and someone joins a space on the same meeting on another platform, that cascade is automatically established. To have distributed location redundancy, all we need to do is put some additional servers in another location and then cluster and cascade them together. Now we have the ability to go up to 8 servers within a cluster without BU approval. But I do know that we've got customers running well in excess of 12, and we've just had another document that we've just released where we've got 24 servers within a single, actually it's over 3 clusters. But it is highly scalable, and it's able to scale to even the greatest of service provider requirements. So it really will scale to meet all of your requirements. So we can utilise, we use DNS, so you can either use GeoDNS or you can actually have different DNS entries for different locations. For example, US.cms pointing to the US ones and the AU.cms pointing to the AU ones, so the endpoints point to those, or within your communications manager you can point to those. So DNS is our friend when it comes to working out which CMSs our devices connect to. No. We can do that via various different ways, but yeah, if you want to, we can take it offline, but DNS is how we essentially send calls. We can, send calls to different locations. So this is, as I mentioned before, this is what we call a single split scenario, and here's all of our component connections. So we have the XMPP load balancer, which is our XMPP proxy, as I would call it, connecting to our XMPP server. Our core bridge connects to our XMPP server, and it also connects to the turn server and to the web bridge. And the core bridge also has an associated database. Now, when we're looking at spreading this over multiple locations, let's say we're going to have 3 single split scenarios. We then are able to create this high highly resilient infrastructure or deployment. So for example, we're able to have the XMPP servers connect and mesh between all of the XMPP servers within all of the locations. And we're able to cluster the XMPP servers together. Likewise, the call bridge can connect to multiple turn servers and to multiple web bridges. And we can also cluster, we can also have the call bridge connect to multiple XMPP servers as well. We can cluster the call bridges, and the call bridges can connect to a database master. And then I'll go through some database concepts in a moment, but essentially within databases, we have a database master, and all of the other databases will act as a slave. So they are fully synchronized from the master. So they're all read-only and synchronized. But we are able to cluster not only the databases together, but also have our call bridges connect to each instance of the database. So this is what a 3-site split CMS deployment looks like, keeping in mind that all of these connections are fully trusted by certificates. Okay, so you need to create self-signed certificates, public CA certificates, as well as trust bundles to enable this concept to work. But what this does provide is it provides it pretty much provides a zero single point or single component failure. So if one component fails, we have multiple other components to pick up the slack or to continue the platform running. So on the database, let's look at how some of the database concepts work. So in this scenario, and this is one of the questions I get asked a lot, is, how does it work in a disaster or DR failover? So we have 3 locations. We have North America, APJ, and EMEA. We have a database master and 2 database slave nodes. Okay, so this is your database clustered together. This is a normal situation, normal environment. Now, it's highly recommended to have a minimum of 3 nodes within your database cluster in 3 geographical locations. And there's a reason for it, and I'll explain it. The latency between the 2 should be less than 200 milliseconds. A master will revert to a slave if it's been isolated from the group isolated from the cluster for 5 to 6 seconds. So our master will revert to a slave. And a master can only be re-elected from the other slave nodes if it can see a majority. That's the key point. It needs to see the majority of the other nodes in a cluster. Okay? So in this case, our 2 slaves can see 2/3 of the nodes within the cluster. So now one can be renominated. So a slave will be promoted to a master if the master can't be detected for 10 to 15 seconds. So now we have a new master within North America. When a node is acting as a slave, it still continues to operate, but we can't make any changes to the space information, to the configuration through the API. Nothing can be modified on the database. It's purely read-only. So it will still function, we just can't make any changes. And therefore, a 2-node cluster does not add any more resilience, because in the event of a failure, the other node or the slave node can only see 1/2 of what's left. Therefore, it can't renominate to be a master. So a minimum of 3 nodes in 3 separate locations is required. Well, it's just really a recommendation. As you can see, that's around that sort of 5 to 6 second mark. That's when the slave will automatically, or the master will be relegated back to a slave. The reason why you want lower latency between the nodes is because when someone adds, for example, a space, that space needs to be then replicated, or that information needs to be replicated to the slave nodes. So when people join the conferences from other locations, so we're able to have efficient bandwidth utilization and set up the cascades, We want it to be able to join the conference and know that the conference is running on that server rather than not knowing that that conference is valid. So the quicker or the faster the network, or the lower the latency, the quicker we have that synchronization. It wouldn't break it. No, it wouldn't break it. It just may add a little bit more of a delay before the conference information is synchronized. What breaks it, as you can see, is between 5 to 6 seconds, a master will be then reverted to a slave. So when we have a true network outage, that's when we have a problem. No. So when the original master, say for example, APJ is now a slave, let's say the network was offline for 30 seconds and it comes back up. It will now come back as a slave because now we have a new master that's running over in North America. If you would like to move that and switch that back around, you need to manually change the master, which you can do, to be APJ again. But because it has been a master and then been relegated down, it will not automatically resume the master state. No, because the masters are actually, I suppose they're all replicated from the master. So when you make a change to one of the databases, they're automatically replicated. So when you make a change, for example, in EMEA, even on the slave, that automatically gets replicated to the master, even though if it's been isolated, it's purely read-only. Yep. So let's look at geo-distribution and pooled licensing. For geo-distribution, once again, we're just really distributing the servers across multi-continents or multi-regions. What it intelligently does, though, is because we have the databases that are clustered, when a video endpoint joins, for example, in APJ and other video endpoints join in North America, because the databases are clustered, it sets up an intelligent cascade between the two locations. Now, along that single cascade, it sends 4 main channel video streams from between that cascade. Thus, as you can see from the diagrams below, we're still maintaining a single platform experience. We're able to see all of the other sites or the last active speakers as if it was a single platform, because we're able to send multiple main streams along that single connection. Likewise, EMEA, we've got the cascade automatically happen there. That also enables us to have efficient bandwidth utilisation because we've only got a single connection between the sites. Now, I've deliberately left something off here. I've actually left 2 things off here. Can anyone tell me what's wrong with this diagram up here? And I've got another prize. I'm going to throw out another headset. If anyone can tell me. Not necessarily, because, for example, North America is not going to see itself when it's speaking. So it'll actually see the last speakers from everyone else apart from itself. So come on, I know someone will pick it. Oh, you. Perfect. There you go. Exactly right. So when we set up a cascade and there is a cluster, we have connections between all locations. So for example, if APJ is connected to North America, then APJ also is connected to EMEA as well. Now, this was one thing that I haven't put in here, and I'll sort of explain this in a moment. This is also assuming that all of the endpoints are connecting to a single CMS in one of those locations. If they connect to multiple CMSs in, for example, the APAC 1 to... Oh, I actually noticed I've got APAC 2 there. Made an error on my presentation. But if they were all connecting across multiple CMSs between that location, and for example, in North America, they were connecting to multiple locations, multiple CMSs in North America and multiple CMSs in EMEA, then our cascades between these also goes up. So let's look at what this looks like. So here we have on the left here 4 participants, and they happen to land on 4 different CMSs in 2 different locations. So in Australia we've got 2 CMSs, and in the US we've got 2 CMSs. So for 4, this is, I suppose, an unlucky situation where it's round robined and all 4 devices have dialed into the same conference. So we've got 4 participants across 4 CMSs, and then we're going to have now 12 ports for Cascade. So now we have to have a link between CMS2 and CMS3. We have to have a link between CMS2 and CMS4, and link between CMS2 and CMS5, and likewise all the others need to have links between them as well. So for 4 participants, we're going to require 12 Cascade ports. And in my opinion, this is fairly grossly inefficient. So in version 2.1, we introduce a new concept that helps resolve this. And that is what we call call bridge grouping. And what call bridge grouping does is logically enables us to associate multiple call bridges within a single call bridge group. And likewise, we've got a call bridge group in Australia there as well. So now, using SIP invites with replaces, when a call comes in and lands on, for example, CMS4, the call will automatically understand that, hey, we've already got that conference running on CMS3. I'm going to redirect that call to from CMS4 to CMS3 using SIP invite with replaces. So this is a communications manager function that enables us to do that. And it does enable us to not only have a lot more efficiencies within the platform, but also increases our capacity because we don't need to have inefficient Cascade ports there as well. We still will have a Cascade link between CMS2 and CMS3, but for 4 ports, now we're only using 6 ports across the whole cluster versus 16 ports, which is a massive saving of not only resources but bandwidth as well. Now, the key point to note is, I think I mentioned this before, it's utilising SIP invites with replaces. So it is currently only supported on Communications Manager and not currently VCS at this point. To associate the components with the call bridge groups, in this scenario here we've got WebBridge 1 and WebBridge 2. And they have explicitly put the call bridge group 1 associated with WebBridge 1 and WebBridge 2. So call bridge 1 and call bridge 2 can now connect solely to WebBridge 1 and 2. In the WebBridge 3, we've got call bridge 3 associated to that WebBridge. So that is the only one, call bridge 3 is the only one that can connect to this WebBridge. And WebBridge 4 hasn't got anything explicitly set within the API, so that any component can connect to that. So if you want to limit what components can connect to what components, and this works the same with recorders, streamers, turn servers, web bridges, you can either explicitly set what can connect to it, or if you don't set anything, then any of the components that are clustered can connect to it. So here's some basic recording architecture examples, and I've put this in to sort of reinforce what I was just explaining. On the left-hand side here, we've got a single server scenario where we have the call bridge connecting to the recorder, as we sort of mentioned before. Now, I've put this in here also. If you want to do some testing of your own, you can actually have the recorder and the call bridge on the same server, but typically you can only get 1 to 2 records out of it. It's not recommended for a production environment, but if you wanted to do some testing and playing around, you can do that as well. With the second one, we've got the call bridge cluster. So all of the call bridges within that cluster can leverage that recorder, and then that recorder will then store the file within the network file system. And last but not least, we have multiple recorders. Now, you've got to be careful with this one. So this call bridge here can actually use any one of the recorders that are available. The problem with that is it'll actually use whichever recorder has the least load. So therefore, where's our MP4 file? On one of the network file shares. You have to go find it. So I just wanted to touch on licensing as well. At the time of acquisition, we used to have a thing called Acano capacity units, and Acano capacity units were based on resources. For every resource, 720p resource you used, you paid for an Acano capacity unit. Since the acquisition, Cisco has changed the licensing model to follow the Cisco multi-party licensing model. So from that, we have the Personal Multi-Party Plus, and I stress plus, and that's because that superseded the Personal Multi-Party licensing. We also have the Shared Multi-Party Plus, which superseded the Shared Multi-Party licensing, and we have the Enterprise License Agreements. The PMP Plus is ideal for named hosts, so we actually allocate that to an individual person. Whereas Shared Multi-Party Plus is really good for endpoints or devices that have no one allocated to it, or we want to license it on a per meeting basis. And once again, enterprise license agreements, they're based on the amount of knowledge workers we have within an organisation, and once that's done, they allocate a certain amount of resources for you to leverage. Now, a couple of gotchas to understand is that prior to 2.1, ad hoc conferences from Cisco Communications Manager had no concept of Personal Multi-Party Plus, so they leveraged a PMP Plus license, an SMP Plus license. The Acano capacity units, which is now called the CMSCU, the Cisco Meeting Server Capacity Unit, yeah, I know it's a mouthful, is still available today, but we're actually seeing a massive decline on people going for that purely because the Shared Multi-Party Plus and the Personal Multi-Party Plus licensing models are very flexible and able to leverage all of the resources. For example, Shared Multi-Party Plus license, a single Shared Multi-Party Plus license will enable a single conference to utilise the whole amount of resources I have within a cluster within a single meeting. So if I had one big conference, I'm only using one Shared Multi-Party Plus license, and I can have as many people in that conference as much as my resources. Now, a lot of people ask, well, how does Cisco Meeting Server know which license to allocate? And it starts off like this. If one or more members who join the conference have a Personal Multi-Party Plus license associated with their account, it'll use one of theirs. Now, if no one has a Personal Multi-Party Plus license, it'll use the person who created the space. If they have a Personal Multi-Party Plus license, it'll use their license. And if they don't happen to have one either, then an SMP Plus license will be leveraged as well. I won't spend too much time on this one, but essentially we do have a lot of migration programs to migrate from the older telepresence screen licenses, the MCU port licenses, telepresence EAs. We have the ability to migrate those over to this new licensing model for Cisco Meeting Server. Usually they have to be under a maintenance agreement or under Cisco support before you can do the migration. And depending on what it is, you'll get a certain amount of resources based on what you're transitioning over. They're different based on what you're transitioning. So let's look at the deployment. I've got 25 minutes, so I'll just want to make sure I get through all of this. This is for the VCS-centric guys out there today, where we have the VCS control and expressway, and all we need to do is create a SIP trunk between the VCS control and the CMS core. We use the CMS Edge for our WebRTC and our Cisco meeting apps, and we still use the VCS expressway for our B2B and our remote endpoints there as well. So it's very simple. SIP trunk between VCS and CMS core, and we leverage TMS for our scheduling. So very simple. It can, but it's not recommended because we have, the SIP Edge itself is it's currently in I suppose a beta mode, or like a forever beta if you want to think of it that. and we've got a strategy to move that over, and I'll go through that in a moment. Likewise with Communications Manager, very simple deployment to the VCS deployment. We create a SIP trunk from Communications Manager to the CMS core. The other key thing to note on this one is we want to add the CMS to the media resource group list to enable ad hoc call escalation from Communications Manager. And once again, we're using CMS as the WebRTC and the Cisco meeting apps, as well as B2B and mobile and remote access. TMS is still used for our scheduling. Now, one of the biggest things that a lot of our customers want to know about is our Skype for Business integration. We have the ability to integrate in multiple ways with Skype for Business. We can act as a gateway. We can also meet on the Cisco meeting server through Spaces. We have direct federation with Office 365. And we also introduce a new concept called dual home conferencing, and I'll go through all of those. So in this scenario here, this is on-premise Skype for Business. We've got the same scenario as our Cisco Communications Manager deployment, but we also have a secure SIP trunk going from the CMS core to the Link front-end server. We have the ability then to leverage the Link Edge if they have one, and Skype for Business users can either come in from the Link front-end server or from the Link Edge server and call natively to any standards-based endpoint within the Cisco video environment and vice versa. So let's look at what that would look like. We have these Link clients dialing or clicking a SIP URI. That call then is forwarded to the CMS based on domain. So Skype for Business does domain routing, and that lands on the Cisco meeting server. The Cisco meeting server then checks to see if it's a space running on the Cisco meeting server. If not, forwards that on our outbound dial rules to land on the call control or the VCS or the Communications Manager, whichever one we're running, and the call is answered at the other end. Likewise, we get full video between the two platforms. It also enables bidirectional content sharing. So it not only does BFCP to RDP, but it also does RDP to BFCP. So we're able to do bidirectional content sharing between the two platforms to provide a single experience. Let's look at dual home conferencing, which is something a lot of people that are typically using Skype for Business as their primary meeting tool, and how that would work. So for Skype for Business, they would click a new Skype meeting within their Outlook client. And what we're doing is we're appending at the bottom of that our connection information for standards-based endpoints, also our WebRTC. So we can either click on a link for WebRTC, or we can even have a static hyperlink for that as well. And then likewise, they can either dial a URI to join that conference as well. And the way that would work is your Skype for Business users would click on their link as they would normally do. As you can see back there, they click on the Join Skype meeting. They would then join the AVM or the conference running on the AVMCU. The video systems would either press the one button to push on their big touch panels, the touch 10s, or dial the conference manually. And that would land on the Cisco meeting server. And what the Cisco meeting server does is says, is this conference a Skype for Business meeting as well? So it also then checks with the AVMCU. And if so, sets up a dual home conference connection. It then establishes that connection and is able to send multiple main channel streams along that single connection, as well as bidirectional content. And likewise, our other video systems can join the Cisco meeting server, and it's not actually, all of our standards-based endpoints can meet on the Cisco meeting server, and all of our Skype for Business users can meet on the AVMCU. The key point to note is that we have the gallery view for the or the Skype for Business clients. We maintain the gallery view for them, and likewise on our standards-based video endpoints, we have the multiple different continuous presence and voice switch layouts on our side there as well. So this enables also us to share content bidirectionally between these platforms, and it really maintains the native experience for both platforms. Okay, Last but not least, we can actually meet on spaces. So the link clients can dial through the Skype for Business platform, have it domain routed, and point to the Cisco meeting server. And likewise, our other standards-based endpoints can dial the conference and land on the Cisco meeting server there as well. Some of the reasons and the benefits of this, or some of the advantages of meeting on the spaces over dual home conferencing or using Gateway, is we're able to leverage things like geo-distribution. We can have tip support for our immersive systems. It's much friendlier on bandwidth. So there's a lot of positives and a lot of benefits to actually meeting on the Cisco meeting server over and above using Gateway services or meeting on the AVMCU there as well. Sorry? What? As a gateway? Or they can work together. You can actually use the Cisco meeting server as a gateway, dialing into a Cisco MCU. Absolutely, yep. So let's look at the Office 365 deployment. And once again, all of these look very similar. We have the Communications Manager clustered trunk to CMS with the CMS Edge. But what we're able to do is register the SIP Federation TLS records to point to the CMS Edge, thus enabling us to do open and direct federation to Office 365. So we can, in cases where customers have only got an on-premise Skype for Business front-end server and they haven't got an Edge server, we can actually leverage the CMS Edge as our Office 365 integration point there as well. Now, everything that I've spoken to you about today has been about having essentially a dual edge strategy. We've got Expressway, which was taking our mobile and remote access. We've got the Expressway also doing our B2B. And I've been talking about the CMS Edge doing WebRTC and Office 365 and Skype for Business integration. Now, the reason why I've spoken about that today is some people have already got CMS or Acano in place, and that's the way that they could do it. But Cisco's future direction is simplification and to leverage some of the infrastructure products that we currently have. Not sure what that box is there, but anyway. What we're doing is actually consolidating our Edge products into a single platform. So you'll see that what we're doing is we're moving all of the Edge functionality of CMS and we're bringing that into the Expressway, purely because it leverages the strong Expressway platform and gives us a single Edge strategy for our collaboration Edge. You'll also notice up there we've got IM&P Federation that we're looking at bringing through the Expressways, as well as all of the modalities and clients to be able to come through the Expressways. So tomorrow we've got a session at 4:30. I highly recommend, because he's going to go into a lot more detail around our Edge consolidation and what we're doing with regards to Expressways and bringing our Skype for Business, WebRTC, IM&P Federation all through this one Edge. So highly recommend going to that session. So let's look at scheduling. Now, scheduling is done by TMS. Our Telepresence Management Suite is doing our scheduling. It's able to provide a single one button to push, and the CMS platform is supported within TMS. It's also able to provide one button to push for the dual home conferences as well. The key point to note is that you guys out there that have already got existing telepresence servers, MCUs, they all can reside on the same TMS, and we can leverage those within the same. So we can literally add CMS to our existing deployments to not only add additional functionality and still leverage that within TMS, just by selecting a priority within TMS of which MCU we want to use first. Now, I was debating whether or not I wanted to put this slide in, but I think it's fairly relevant, and that is TMS is supported, CMS is supported by TMS, but there is some caveats, there is some limitations today. And that is, some people may have been familiar with the Conference Control Center, the Java-based applet where you can actually view all the conferences within TMS. Java itself has actually been deprecated, and to add CMS within that was going to take some engineering time, and to be honest, wasn't the future direction of where we wanted to head. So currently there's no conference monitoring or conference control center for CMS. And likewise, there's no CDR reporting on TMS. But saying that, we have the ability within CMS to export all of the CDR information to an external CDR server through the API. So we can still address that solution. Within the scheduler, we also, you guys out there who may have already got the TCS or the telepresence content recorder, you'll notice that when you're booking within TMS, you had that recording function or tick box. That doesn't work with CMS. Okay, so you need to be aware of that. There's no TMS PE-based provisioning, so CMR, on-premise CMR, we don't do that through TMS PE-based provisioning in TMS anymore. We actually do that through an AD integration within CMS. So although it's not available in TMS, we actually do that function within CMS through an LDAP import. There's no CMR hybrid support, so no integration with CMS into WebEx today. There's no bridge reservation or calculation, so we can't reserve ports or reserve resources for a specific meeting, and there's no bandwidth restrictions, okay? So, yep. Yep. I say today, yeah. I can't really comment too much further on that because it is forward-looking, but it's not available today, but it's not to say that it may not be available in the future. Yeah, well, once again, I can't really talk about that too much because that's more of a Spark platform feature. So the other thing that I wanted to really touch on is the API. And the API is what this platform is heavily reliant on. Everything that you want to do from customization and to doing all the functionality is done within the API. So the API is literally used to do all of the advanced functionality within the Cisco meeting server. It does things like the server branding, enables you to set up custom calling scenarios, for example, lecture modes, host and guest pins, setting up DTMF controls for specific functions and specific users. It really does enable us to do all of the advanced features within the Cisco meeting server. Now, I don't expect you to read all of those because there's a hell of a lot of them, and I refer you guys to the CMS 2.1 API reference guide, but there is a lot of API commands that you can leverage. But the biggest thing that I wanted to, I had to get my head around, and hence I want to pass on to you guys so you have a good understanding, is around what these does. So in this scenario here, I've got two spaces. I've got one on the left with accessing the conference through meet.abc.com with a conference ID, as well as on the right-hand side, we have a space as well. So the guys on the left, they just dial meet@abc.com and they join the space. Now the call leg attribute operates at an endpoint level. That tells us things like, packet loss, tells us things like, is the endpoint muted, very endpoint-specific parameters. The call attribute pertains to the space. Is the conference locked? Is the conference being recorded? Is the conference being streamed? That's the call attribute. The problem is the call needs to be active first before we can actually see or modify or change any of these parameters. So how do we address that? And the only way we address that is through profiles. Now we can apply profiles at a system level, at a top level, and we can also apply them at a space level. The problem there again is it may not be granular enough for what we want to achieve. If we apply a call leg profile for the space, then everyone within that space is going to have that call leg profile applied to them. So how do we get granular down to each individual endpoint? And the way we do that is through access methods. And access methods enable us to have a pre-application of our profiles, our colleague profiles, our call profiles, to the space by access methods. So for example, access method number 1 enables us to dial host@abc.com, so he has a different URI, he dials a different PIN number, and that applies colleague profile number 1. So that's for our host to dial in. Our panelist will dial panel@abc.com with a different PIN number, and he'll have colleague profile 2, and he may have different rights. For example, the host may have the right to mute everyone in the conference. The panelist may have the ability to start a recording and mute the conference as well. But colleague access, or access method number 3 for the guest, we want them to have minimal access. Do we want them to be muted on join? Do we want them to have the ability to mute all? Of course not. Do we want them to start or stop recordings? No, we don't. So we actually put that in the colleague profile that they do that. So when they join in via that access method, it pre-applies that colleague profile to them calling in. And that's the way we do host and guest pins. That's the way we do different rights for different people dialing into a conference. So we're able to have multiple URIs applying different colleague profiles coming into a space so that various different people have different rights and accesses to be able to do things within a conference. For example, lock conferences, deny someone from sharing content within a conference, be able to start and stop recording and streaming, and there's a whole lot more. And that's how we use APIs to customize and to deliver our solution that we want for our customers and partners. Yep. Yeah, we use things like Postman. There's a lot of RESTful API applications that enable us to do that. It's really designed for the ability to write your own applications to leverage those commands. But if you want to use Postman, that's a good diagnostic tool. It's a Chrome add-on, and yeah, easy to download. There is. I don't know how much I'm allowed to say within this session, but if you come see me afterwards, I can talk to you a little bit more about what we're planning on doing in the future. But there is stuff in the pipeline. Last but not least is, here's the REST API structure. Now you'll notice that we're able to have colleague profiles, DTMF profiles at a top system level, even branding profiles at the top level. And likewise, we could do it at a tenant level, at an IVR and space level. And then right at the very bottom, you'll see access method and co-space users. Now, the way it works is the lower level, if it has one of these profiles applied, they override the levels above it. For example, if I have an access method, a colleague profile applied at an access level, then that call profile overrides anyone else's call level profiles over and above that. So it is a hierarchical structure that enables you to define that. In summary, for new deployments, we use Cisco Communications Manager as our SIP core control. Our express way to do our third-party endpoint registration, H323 registration, mobile and remote access, SIP and H323 interworking. That's all done on the expressway. Oops. The CMS core is our multi-point conferencing server, and it's our preferred conferencing server within the collaboration architecture today. The Link Skype for Business Gateway, which provides our RTV interworking, it does all of our interoperability and our application, the Cisco meeting apps. And the CMS Edge, well, once again, that piece of the puzzle is required today, but you'll see if you attend the session tomorrow that is something that we may not need in the very short-term future. But that today provides our WebRTC gateway, our meeting apps, and our Office 365 gateway. Now, in summary, I won't spend too much time on this slide, but I wanted to summarise what you guys have learnt today, and that is providing a SIP trunk between our preferred call control and our CMS core, adding the CMS to the media resource group to provide ad hoc conferencing. To add additional resiliency and scale, all we need to do is add additional servers. Very simple. If we want geo-distribution, put CMS servers in multiple locations, keeping in mind our database requirements. Conference scheduling, that's done through TMS. TMS is our conferencing scheduling platform. For recording, all we need is the recording server and a network file share and the license to do that. For streaming, we use the streaming component, and currently today vBrick is our supported streaming server, but it is able to be leveraged using other streaming server platforms. It is standards based. For B2B and mobile remote access, we use the Expressway, and very shortly, as I mentioned before, all of the workloads will be combined into the Expressway. But today, we use the CMS Edge for our Cisco meeting applications, WebRTC, and our Office 365 direct and open federation. Now, as I said at the start, I wanted you guys to be able to walk away out of this session, but to be able to build your own single combined deployment and to be able to spin it up in your own lab on your own small servers, to be able to have a bit of a play and a bit of an understanding. Being that I've only got a couple of minutes left, I won't go through this in detail, but as I mentioned before, the components that you need are very simple to set up. All you need is to download the small virtual machine and install that, keeping in mind the virtual machine requirements. We have DNS-A records that are required and XMPP records that are required for our call bridge and our web bridge and our XMPP server. And it's really as simple as there's only like 5 CLI commands to turn on each of the components. For example, to enable the call bridge, all we need to do is say what interface on the virtual machine are we listening to, and apply the self-signed certificates to that call bridge. And likewise, the web admin, being that if we're running it on the same server, we may just offset that to port 445 or something else that's not being used. And our web admin enables us to manage the call bridge. Create a SIP trunk from our call control, so if you've got VCS or something else, very simple to do that, just a SIP trunk between the two platforms. Create a space and an IVR, and that'll work as a conference bridge. If you want to enable WebRTC, you turn on the XMPP server, you turn on the web bridge, and then you have WebRTC functionality. It's very simple and you can do that very quickly. Key takeaways: Cisco Meeting Server is our lead conferencing solution. We have migration paths from telepresence server through to Cisco Meeting Server, and it's very scalable and able to grow with your organisation. It enables us to remove any silos and technology islands between our environments that we've got, and really does enable that any-to-any vision of connecting anyone into a conference. Efficient bandwidth utilisation through geo-distribution, so we can save on bandwidth when we place servers across multiple locations. And we can add new modalities like WebRTC, recording, streaming, all within the same platform. Now, I've got, looks like about a minute or just less for questions. Yep. Yeah, well, Jabber's part of Communications Manager. It leverages CUCM and our IMMP server. So that is just a soft client. I mentioned that at the start, where they can actually just... No, they're two very different applications. Jabber is a soft client that does instant messaging and presence, where the Cisco Meeting app is really video-centric, video-focused. So the only places that we typically use those are for external connectivity for customers who haven't got Jabber, or we're not going to give Jabber to customers, or for video-centric people within our organisation. Essentially, the WebRTC is really where we leverage that functionality, you know, the any-to-any, having people clicking on a link from a web browser and joining our conference. And the other participants within our conference can also be Jabber Jabber users as well. Jabber guest, that's a very good question that we get asked quite a lot. Does this mean the death to Jabber guest? Jabber guest has a different, I suppose, position within the architecture, and the reason being is that the WebRTC here doesn't have an open SDK to be able to integrate that into our own point of sale machines or kiosks or anything like that. It's really consumer focused, whereas Jabber guest can be fully integrated into our own customized portals, and that's where its place is. Yep.
In regard to the current split model where you've got Edge and the
Yep.
and the CMS Edge.
Yep.
It's like from your public DNS SRV record.
Yep.
You're not going to be able to use the same domain to keep your meeting server as to keep your internal, say, users on Jabber endpoints?
Well, for example, Jabber's going to be utilising a different port ranges, so different, I suppose, SRV records. But you're right. I mean,
Sorry, not for Jabber registration. But let's say if you want to make an internal video call.
so B2B, the recommendation for our business-to-business communication is to use expressways. We don't want to use the CMS edge, or I should say the SIP edge within the CMS as our B2B. The full recommendation is to use our expressway technology for that, purely because it does offer much more than what the CMS edge does offer.
Your B2B to a space from an external business to a space, depending on your express.
Yeah, and that's why if you go to that session tomorrow, you'll actually see that we're collapsing all of that into a single edge technology, and you'll start to see, for example, currently the SIP edge is in a beta mode, and you'll see that deprecated very quickly. We can now do Office 365 Direct and Open Federation through Expressway. So that's something, and this is where it was a bit touchy on this presentation to present what, because customers are all in different positions, and some people are using older call control, some people are using various different. So for example, VCS customers may choose to, if they haven't got Expressways, use the SIP edge, but it really comes down to what you're trying to do. But at the end of the day, our recommendation is to use the expressways for all B2B and mobile and remote access, and only use the CMS edge for WebRTC. And once again, even that is being collapsed into the expressway and the Cisco meeting apps. Yep. So we do have within Cisco Spark a meeting room, so feel free to jump on that, ask me questions. I'm happy to respond to them. I'll be on Meet the Expert on Friday, so feel free to come in and book some time with me and to sit down and run through various different things. And the Spark room will be open for some period of time after Cisco Live there as well. And please rate me on how you thought I was today. I like very high scores, like everyone does, so thank you very much.